Now, we've just covered accuracy as a method of evaluating our classification models. And you might be thinking, why can't we just leave it at that? Well, as we start to go through these other metrics here, you'll start to understand why it might be important to get a few more different evaluation metrics on the board rather than just accuracy. In my case, when I was first learning how to build classification models, I would always think, yeah, just higher accuracy is better, right? And then slowly after looking at different examples, I started to realize, okay, now I see the value of using other metrics like these. But let's not talk about it. Let's see it in action. The next one we're going to cover is the area under the receiver operating, so area under the receiver operating characteristic curve. The beautiful thing is it's also known as AUC, so area under curve, or ROC, so receiver operating characteristic. So let's do this. ROC curve. So these are the two things you'll look out for. Area under curve or ROC curve. Maybe we'll put it here. AUC or ROC curve. Beautiful. So if you hear someone talking about AUC or ROC or ROC or something like that, they're probably talking about this metric here. Now, what does a ROC curve measure? Well, by formal definition, a ROC curve is a comparison of a model's true positive rate, aka TPR, versus a model's false positive rate. Let's write that down here. Are a comparison of a model's true positive rate, which is also known as TPR, versus a model's false positive rate, which is also known as FPR. Now you might be wondering, okay, what is a true positive and what is a false positive? Well, let's have a look here. A true positive equals model predicts 1 when truth is 1. Does that make sense? So in our case, if we have a look up here, if our targets are 1 or 0, a true positive is when our model predicts a 1, the real label is a 1. Okay, yeah, that makes sense. So if we go here, a false positive is model predicts 1 when truth is 0. So why is it called false positive? Well, it's because it's predicting 1, so aka the positive class has heart disease, when the truth is actually 0. So it's giving us a false positive sense that a person may have heart disease in our particular case for our heart disease classification problem. And then if we go here, a true negative equals model predicts 0 when truth is 0. So that makes sense. So that's predicting the model is getting the right prediction there. It's predicting someone doesn't have heart disease when they actually don't. That's great. And then a false negative equals model predicts, what do you think this one will be? False negative. If we look at false positive, a false negative is when model predicts 0 when truth is 1. So that's because it's predicting not heart disease when it actually is heart disease. Right, so now we know these, we can see that a ROC curve is a comparison of a model's true positive rate, TPR, versus, typos everywhere here, Daniel, come on, versus a model's false positive rate, or FPR. So now we know this, let's see it in action. So we can do this using Scikit-learn's metrics library. We're going to import ROC curve. So see how I was saying, ROC curve, ROC curve, and then we're going to make predictions with probabilities. And how can we make predictions with probabilities? We saw this in making predictions. We can do that with yprobs equals clf.predictproba for probability. We're going to make some predictions on the X test data. Now, I just want to make sure, maybe we do that, we create X test, just to make sure it's the right X test data. X test, etc. So we want to go here, X train, X test, Y train, Y test equals train test split, X, Y. Test size equals 0.2. Wonderful. And so now we can do that there. Because a ROC curve is a comparison of a model's true positive rate versus a model's false positive rate, we want to only keep the positive classes. So actually, let's see what yprobs looks like. Yprobs, why hasn't this worked? What do we got here? This random forest classified is not fitted yet. Call fit. Ah, that would make sense. So we want fit the classifier. Of course, you can't make predictions without fitting them, without the model learning any patterns. So we're going to fit it here, then we'll make some predictions, and we'll have a look at this. Maybe only the first 10, so we're not taking up heaps of space. Okay, beautiful. And so because ROC curve only is a comparison of a model's true positive rate versus a false positive rate, we only want probabilities that the model has predicted for the positive class. So if you imagine here, our model's trying to predict 0 or 1. This is the probability that the label is 0. And this is the probability that the label is 1, and so on for all of these samples until it finishes up. So there's going to be however many are in the test set here. 61. So there's going to be 61 of these. So essentially what we want is yprobs positive. So this is the probabilities that it's the positive class, aka 0 is the negative class, and 1 is the positive class. Yprobs, we're going to use some slicing here, but only column 1 of every row. So we can do that, just so you know what's going on. Positive. And we'll only look at the first 10 again. So does this make sense? We're getting 0.43, yep, 0.77, yep, 0.48, so on, so on, so on for the entire list of yprobs. And now we can calculate FPR, TPR, and thresholds. So we'll go FPR equals TPR, thresholds. Why do I know this? We'll see this in a second. Why do I know that this is going to be FPR, TPR, thresholds? We got ROC curve. We're going to pass it ytest and yprobs positive. Now, how would you figure out what ROC curve returns in this case? Well, what I would do is I'd press Shift-Tab, and this is how I know. So we got ROC curve, it takes ytrue, so that's our test labels. It takes yscore, so that's our yprobs positive. And if we come down here, compute the receiver operating characteristic, ROC, yep, beautiful. Now parameters, ytrue, yscore, target scores can be either probability estimates of the positive class, confidence values, or non-threshold measures of the decision. So that's the probability estimates of the positive class. That's where we got this slice from, right? And then if we come down here, it's going to tell us what it returns. FPR, increasing false positive rates such that element I is the false positive rate of predictions with score above thresholds. TPR, so that's a true positive rate, and thresholds. So that's how we can figure out what a function returns. And again, that's just viewing the doc string in a Jupyter notebook. You can always look at the documentation for this. If you wanted to do so, you might look up something like how to calculate ROC curve for Scikit-learn. So then we're going to check the false positive rates. FPR, beautiful. So that's giving us a big array. But looking at these on its own doesn't really make much sense. It's much easier to see it visually. And since Scikit-learn doesn't really have a built-in function to plot a ROC curve, what we might have to do is, and quite often you'll come across this, right, is you'll have to find a function or write your own that'll do it for you. So that's what we're going to have a look at in the next video. We'll plot a ROC curve, and this function here, ROC curve, will start to make a bit more sense rather than just be an array of numbers.